This is the screencast for section 2.1, example 1, finding an average speed. So in this section, we're going to look at rates of changes and limits. And in this particular example, we're going to study the average speed. Now, if you have a car that travels on a highway, it's not always going 60 miles an hour. Sometimes it goes less, sometimes it goes more. But we use the phrase traveling at 60 miles an hour kind of as an average speed. So in other words, we take the actual miles an hour that the car is traveling over a span of time and find out its average speed. Average speed is found by dividing the distance covered by the car or object divided by the elapsed time, so the amount of time it took up. In other words, it's kind of like the car's slope. So in example 1, we're going to study a rock that breaks loose from the top of a tall cliff and find its average speed during the first 2 seconds of the fall. Well, we know from pre-calc that y equals negative 16t squared plus v sub 0, the initial velocity, times time, plus the initial position, is the formula for vertical free fall. Well, if you know from your car's speedometer, a speed is never negative. A speed is always positive. So we're going to take y equals positive 16t squared. We're going to make the initial velocity 0 because this rock is just breaking loose from the cliff. And then we're going to make the initial position also 0. So we're going to say if the rock falls 1 foot, it would be a position of 1 foot. If the rock falls 5 feet, it would be a position of 5 feet. So its initial position is 0. Therefore, the function that we're using is y equals 16t squared. Pretty easy to work with. That function is a parabola. The parabola that at time 0, the rock has fallen 0. Well, it doesn't give us units, but we're going to use feet and seconds. So at time 0, 0 seconds, the rock has traveled 0 feet. At time 2, the rock has traveled, let's see, 16 times 2 times 2, so 64 feet. So to find the rock's average speed, now we know it didn't travel this speed the whole time, but it started out at 0 feet per second, ended up at a much faster speed than that, but we'll find its average speed. So we're going to take the change in y over the change in x, and we get 32 feet per second. So basically what we're saying is, from time 0 to time 2, this rock had an average speed of 32 feet per second. We know it started out at 0 feet per second and ended up way faster than that. But if we had a second rock that was always falling at 32 feet per second, the rocks after 2 seconds would be at the exact same spot. They'd be at that 64 feet. Then now try problem number 1 wants us to find the average speed during the first 3 seconds of fall. So if you can picture that, the rock is going to be falling even faster between 2 and 3 seconds, so we should have a faster average speed of the rock over the first 3 seconds than over just the first 2 seconds. Well, the position at time 0 was still 0 feet. Then the position at 3 seconds is going to be 144 feet. So the average speed this time is 48 feet per second. So between seconds 2 and 3, this rock is traveling a lot faster than 48 feet per second, but over the first 3 seconds, it had an average speed of 48 feet per second.